Thank you. It's fantastic to be here. I really appreciate the opportunity. I feel like having my hands full like this is kind of impeding my Italian heritage, and also I feel like I'm in a karaoke bar, so this talk could go a number of different ways. Okay, 1 second. Maybe I should start singing, just so you guys are entertained in the meantime. I may as well just start by giving myself a bit of an introduction. I work at a hospital in White Plains called Burke Rehabilitation Hospital, and I'm the Director of Telemedicine and Virtual Rehabilitation there. I'm also a faculty member at Cornell Med, and I've sort of got a background in, I started out life as a physical therapist, then did a PhD in neuroscience, and then sort of went through the whole postdocing period through Boston and New York, working at places like NYU, Harvard Med, MIT, all the time looking into computational neuroscience and brain-computer interface, and really looking at different ways of using technology to help patients in difficult situations. And yeah, now I've sort of landed in this faculty position where I'm trying to create a telemedicine system. So hopefully today, what I want to do is just sketch out my basic thoughts about what telemedicine should entail. So I think the most important thing is patient engagement. Like, this is what we're here, this is what we're here to do, is to get patients and who are having trouble managing the conditions that they have and get them involved in their own wellness. So that's basically my goal, is to say, well, actually, it's not on everyone else to make sure that you're doing your exercises and make sure that the exercises are perfectly calibrated for you. It's a team approach. Everyone needs to be involved in this, including the person who's being treated. And so how can we do that? And you know, a few of the things, the little, on this messy little mind map, you know, user interface is so important. Creating friendly tablet-based interfaces for therapists and for patients, that a therapist, a busy clinician at a glance, can take a look at their patient and go, yes, in a snapshot, this is exactly what is going on with my patient right now, with very detailed metrics. I've got therapy gaming experience twice there. I think that must mean that it's twice as important as everything else. Really, what I'm trying to do, a large part of what I'm trying to do with my research, is to make exercise therapy for a number of conditions fun. And then I also think that it's just really important that in terms of engagement, we deliver the results of the exercise therapy to the patients in ways that they can understand. So rather than saying, oh, you have scored this on a Fugelmeyer, which is what clinicians actually currently do right now, is, oh, this is your score on the Fugelmeyer, which means that you're in this percentile and these are the things that you can do. How about, because that doesn't mean anything to anyone, I'm a physical therapist and that barely means anything to me. How about instead of that, we say, well, you said to me that it was really important to you that you can brush your teeth. And because we've got this wonderful wearable watch that you've been wearing, and we can extrapolate some kinematics from that, we can tell you that because you did your exercises this week, you are 5% closer to reaching that goal. That's something that is far more accessible and far more understandable to patients. So that's some of the stuff that we're trying to do. There's also a huge arm in terms of scientific discovery. These devices are giving us unprecedented ability to collect data, to analyze data, and to develop new assessment protocols for some of the assessment protocols that are commonly used in the clinic that are actually just falling behind. They're no longer relevant, they're no longer effective, and we need to do better. And suddenly we have the technology to do better, and it's very, very exciting. And I don't know really what to call this, but I'm going to call it PR. I think you can have the best telemedicine service in the world, but if you are not telling people about it in the right way, it's going to appear threatening, and it's going to appear you know, not as valuable as it actually is. You know, there is a huge barrier that we need to address to effective telemedicine, where people are very wary of being spied on. Remote patient monitoring is a very scary term, and I don't like to use it very often. But and it's an important consideration. Like, part of this entire patient-centered approach is to actually find ways to get people involved in different therapies in ways that they don't feel threatened, they don't feel afraid. So I'm just going to start off by talking a little bit about the patient engagement side and some of the things that I've been doing to get that off the ground. So my lab up in White Plains has been running a number of tests with things like the Oculus Rift, the Microsoft Kinect 2, things like the Myo. So we've got a very strong bias toward neurological rehabilitation. And what we've been finding is that things like immersive virtual reality can really help patients who have absolutely no movement in their affected limb. If we put them in an immersive virtual reality environment and have them look down at a limb that is no longer paretic and no longer damaged, and they can watch it actually moving naturally and healthily, this improves their motor function. In patients who have complete flaccid paralysis, this will improve their motor function because just the act of observing these actions sets what have been colloquially known as mirror neurons into motion, and these can start to revive some of the damaged motor pathways that we couldn't otherwise get to. The Microsoft Kinect is fantastic because it allows us to do very non-invasive kinematic and kinetic monitoring of patients. And we've been building it into a number of different fun protocols where patients are playing like virtual Candy Crush and things like that. So really using the device to stretch out of their sort of safety net and work on their static and dynamic standing balance. We've got things like virtual yoga and virtual Pilates to sort of really engage people, because people, people don't like to talk about being in rehab. I mean, when it comes to like the annual time I go to the gym, you will not shut me up about it. I want to tell everyone that I've been to the gym, but if I have hurt my knee or I've hurt my back and the physio gives me exercises, I want to talk about it because that's rehab. What we're trying to do is we're trying to sort of push the idea that actually, there's no real difference between rehab and general activity, and general activity angled toward improving your wellness. So there's no reason that a stroke patient can't get involved in a Pilates class to improve their balance. And there's no reason that Pilates class can't be sort of scanned on the Kinect to make sure that they're getting continuous real-time feedback about exactly how they're doing. And then down in the corner, we've also got a state-of-the-art, at Burke, we've got a state-of-the-art robot rehab lab. And there's another convict over here, Dylan Edwards. He's an Australian guy who works in the lab. He's been the director of the robotics rehab department at Burke for about 8 years, doing really incredible stuff with stroke patients. So it's a really hopeful time. I've also been working with a company called Jess Therapy to sort of set up a whole battery of at-home tele-rehab services. So one of the most simple games that we have here is called the Jess Aircraft game, where we're using the leap motion. I'm sure everyone has heard of the leap motion before, but if you haven't, if you've been living under a rock, it's a $70 device. It's about this big, and it works on just infrared emitters and receivers. If you pop your hand over it, it can track what your wrist is doing, some of what your fingers are doing, and a lot of what your forearm is doing. So and it comes with an open SDK. So we started building some video games around it. Oh, can we play the video? Maybe even both of them at once. Just click on them. Yep. Cool. So we designed this game to improve wrist extension and forearm supination, which are two movements that stroke patients have particular difficulty performing, and they're really important functional things for things like opening a jar or opening a door, like twisting a doorknob. Things like that are really important, and stroke patients have a lot of trouble moving into supination and wrist extension. So we designed this very simple game where they control an airplane and they've got to go through obstacles and shoot at targets and all of these little things. And it just makes therapy a little bit of fun, but the real value is it's continually tracking all of the movements that they're performing, so that at any time when we send a patient home with this and we say, we want you to do this X times a day, we can, for the first time ever, we can actually say, we can say, did you do your exercises? They'll say, oh yeah, every day. And we can say, actually, you did it Monday, Wednesday, and Friday, and only for about 3 minutes. So what's going on? Are you bored? Is it sore? Is it, like what is happening that is forcing you to not do your exercises, and how can we help? And that is a unique opportunity that has never happened before in rehab. Ordinarily, we've just had to take our patient's word for it. Now we can actually find out why, and not confront them, but actually try and work out what the problem is. Like, what is it that is that's stopping you from doing your exercises? And to give you an example, I thought that this was great and fun, and we got a couple of stroke patients on it, and the oldies loved it. So we said, great, let's apply this to cerebral palsy patients, because it's video games, they'll love that. Nope, about a minute into it, these kids sort of like threw it off the table and said, we don't want to play this anymore, it's boring. Because apparently, unless you're blowing things up every second and you're an 8-year-old, it's just not fun. So we've got a few alterations to make to hit the kid market, because they're absolutely ridiculously jaded. But we'll see how we go. So to sort of summarize that aspect, just a few other things. We really want all technology to be accessible. I get a headache when I read an article in the IEEE about someone who's built one more sensor that, it cost them about $400, but it's perfect for tele-rehab so long as you use their exact system, and they won't be manufacturing it, so you've got to email the author and hope that he likes you enough to send you one sensor. That isn't going to make tele-rehab go anywhere. What we need is to repurpose existing technology. We need to reach out to people who are making sort of sensing devices en masse and say, yeah, we want 1,000, and we want 1,000 right now, because we've got 5 hospitals who are willing to engage in this multi-site trial, not, let's stitch together a device ourselves and use it. And that might just be because I'm lazy, but this has been my approach. We also want raw data. So Fitbit, Jawbone, I'm sorry, we want access to the raw data, not some invented metrics about how you're doing. So what's really important for us is that we get APIs and SDKs that give us access to the exact raw data, because this is science that we're doing. Sometimes it sounds like marketing, but it isn't marketing, it's science. So we need some raw data. And then right now we're building a lot of systems for assessment, treatment, and remote patient monitoring. But I'm going to just go on to something a little bit more exciting. So I'm going to skip the scientific discovery, because no one wants to hear about science. Let's talk about PR. So when I talk about vision projects, looping back to what I was saying about trying to engage people in rehabilitation, trying to actually do away with the word rehabilitation and actually sort of talk about just engaging in wellness. I've been working hard to sort of find a lot of partners who are interested in moving this story forward. One of them is Red Bull. Red Bull, I don't know if you know, has a high performance division. They have been doing a number of amazing projects, from dropping people out of space to helping people make better music, to helping people ride bikes faster. So I got involved in a project called Project Endurance, and the whole idea of this project was to see if the brain has a fatigue signal. If you're working a muscle to fatigue, does the brain actually send out a signal before the muscle is completely fatigued? And if so, can we switch that off? Can we switch that off and say, well, actually, don't worry about that. That's an old evolutionary signal, and we actually we need you to keep going. And this is important in sports, because people want to go faster, and they want to go faster for longer. But it's also important in rehab. So we have spinal cord injured patients, we have stroke patients who, if they're reaching the limits of what their brain is saying they can do, if we can implement a modality like transcranial direct current stimulation and stimulate their brains and say, actually switch off that message, you've still got a little bit of juice left in your muscles, we can get more out of their rehab. And that's what we were hoping to achieve with Project Endurance. And what Red Bull was extremely supportive of for us was actually pushing this idea of this is for everyone. We happen to be working with 4 of the best endurance cyclists in the world, but they are up here on the spectrum, but what we actually have is a spectrum of ability. Down here we have someone who is completely in a locked-in vegetative state, and right up here we have the best endurance athletes in the world. But every single person along that spectrum is doing the same things to improve. And that's the message we're trying to say. We're trying to rebrand rehabilitation. It's no longer rehabilitation, it's just engaging in wellness. You'll hear me say that like a broken record. So here's the video. Can we hit that? Here we are at Red Bull headquarters, and we've got some of the best athletes and scientists in the world here answering the question, can we tell our muscles to keep going even when our brain is telling them to stop?
It's easy to turn off the muscle when you get tired and you feel like you can't do it anymore. But if they shut the brain off, then who knows how far we can go. It's definitely uncharted territories.
So we are looking at the role that the brain plays in the fatigue process.
There's a mismatch from what the person can do and what the biological reserve is, and we're trying to understand that better so that we can design better training programs for these people.
They're monitoring everything that you could think of on your body. So there's tape around your neck, all over your body with electrodes, on your calves, on your quads. It's not very comfortable, but I mean, it's super cool what they're doing.
That's nice.
We're going to do a whole bunch of physiological and neurological testing while we're exercising.
We hold a paddle next to the head. It delivers a large but very short magnetic field, and then the muscle twitches involuntarily. So it makes the brain more responsive, and we're studying to see whether that happens in these athletes or not.
So it's very interesting because you combined physiology, muscles and so on, but you also including the brain.
You would not find this many scientists from so many disciplines working together with very high performance athletes.
So we've been here for 3 days. It's been really exciting and everything's been going smoothly. Tomorrow we take it into the velodrome. Things are going to be a lot less controlled. Very excited to try it out and see what we get.
How can we change our sport? You know, no one else from my sport's doing this.
I hope that the athletes will get out of this a better understanding of when they're fatiguing, how much of that is their perception and how much biological reserve they might have. And we should be able to answer those questions using these techniques.
So for here to get out and actually ride the velodrome, it's been pretty fun. I mean, it's hard work to do 16 laps, but it's definitely fun.
I'll be really interested to see what they come up with over the next couple weeks, and we'll just kind of see what happens after that.
They had us do another 4-kilometer time trial in the velodrome here. They set up a LED lighting system. From our best time yesterday, we could see the pace. So you're kind of chasing this light in a way. What they didn't tell us is they actually made it faster than what our best pace was.
I thought we were going to race against each other or race against the moto.
Yeah.
But you had us race against ourselves, a faster ourselves.
Yeah.
You know, 2 of us had faster times, and then 2 of us actually, it kind of went the opposite, and they had slower times, I think, because they blew up and trying to chase the light, and they went too fast. I don't know what all the data is going to tell us, but it was definitely pretty cool to actually have like a competitor next to you. That's you.
Really, the whole thing here is amazing because it's just really taking science to the limit. It's really testing the limits of what a controlled experiment is. And in my opinion, that is the only way that you can push scientific discovery forward and technological development forward is by saying, well, there's so many people that would say this project is too ambitious. We're going to do it anyway, and we're going to develop technology based on what we find here. So it's really exciting. So yeah, that was Project Endurance that we finished up, and now I seem to have become the guy that Red Bull asked for impossible things. So the next thing they said is, oh, you know, since you're good at wearables and finding people who do wearables, we now want to record eye tracking and EEG from surfers while they're in the water. So that's my next project that launches in August. So if anyone's got any ideas, I'll hear them now. So the other element of PR is service. I think that as people working in telemedicine, my team, I always try to sort of express the idea that we need to be showing people that technology is making things better and not worse. People are very afraid that technology is going to decrease the personalization of healthcare, and what's important is to show that actually it's going to increase the personalization of healthcare. Having all of these metrics is going to improve the way that your clinician and yourself understand your body and your condition. So we're really sort of pushing the idea, and I volunteer a lot of my time to a group called Not Impossible. Not Impossible is a fantastic group that crowdsources solutions to problems. I'm going to talk a little bit about a couple of projects that we've got on the go, and then I think that'll be me done talking. So the first thing I want to talk about is the Brainwriter project. This is a little clip of the iWriter.
Temp is the ultimate graffiti artist.
He's put Los Angeles on the map.
He's always been next level. He probably is the most versatile artist.
Temp is an innovator.
People respect him. They know who he is. He's an OG.
He's such a force.
Nobody compares with his style. He's one of the top 5 in the world. Him being laid up, I don't think about that.
When you get diagnosed with ALS, it's a traumatizing experience because you're told you have only so long to live and you will spend your time completely trapped inside a body that doesn't move anymore.
I hate seeing him like that.
There's so many times where he could have just slipped away, but he's sticking it in there.
It's all about that one phone call that I almost did not pick up. Mick Ebeling was on the other end.
Had to be involved with Temp and just helping him. I had no idea how I was going to come through on what I committed to.
Our writing culture was born of making something from nothing. I laid in bed, exploding with ideas that branched out from that initial concept. That's when I knew I wasn't done yet.
So that was the iWriter, and Temp was using that to create art and communicate with his family, which was amazing because he was quoted about $30,000 to $40,000 for a device that could do this, and we made this for $15. Just so you know. Then it was reliant on Temp being able to blink. He lost the ability to blink. That was when Mick called me up and said, "I need you to make me a Brainwriter." Our initial prototype was a bottle of whiskey, an operational amplifier, a dirty sock, which held some very homemade electrodes, and we had EEG signal. We then upgraded to a bit more of a wearable, but not really still pretty primitive design of EEG design, but we made some partners along the way, a great New York startup called OpenBCI who have been making sort of accessible EEG amplifiers. And we've also been working with artists and different sort of tech people to create the next generation Brainwriter, which is sort of the funky next generation device. So we've been working on this for about 11 months, and we are launching in a few days. Tonight I'm flying out to London to launch the Brainwriter project at the Barbican in the UK as part of their Digital Revolution exhibition. And so we've got this amazing thing set up where people can see Temp's story, they can see the evolution of design, and then they can actually play a video game that is powered by the Brainwriter. So I haven't slept for a while, but I think it's going to be worth it. I'm just going to hit you guys up with one more project that we've been working on, which is Project Daniel. This was Mick kidnapped me one day. He had read an article in Time magazine about Daniel Omar, who had had both of his arms blown off by a bomb in Sudan. And I was chatting to Mick in a cafe here in New York, and then the next thing I knew, I was in LA for 4 days with a team of equally crazy people not sleeping until we had created a 3D printable prosthetic. And this has been an amazing journey. We launched in November when Mick actually, with a team of 4 people, dropped into the Sudan and into a war zone and created a self-sustaining prosthetics lab out there. We recently won 5 Lions at Cannes for our work, and I'll just show you the video and then I promise I'm done. So.
I don't believe that you can fix someone. That was never my goal here. Daniel was 14 when the bomb hit. Hiding behind a tree saved his life. But after losing both of his arms, he said he wished it hadn't. He had lived 2 years without arms. Daniel is just one of over 50,000 amputees left in the wake of the bloodiest war Africa has ever known. The plan was to go to Sudan and 3D print prosthetic arms for Daniel. But that was just the beginning. We wanted to leave his village with the tools and knowledge of how to create these prosthetics long after we had gone.
This is going to be the hand that we work on for Daniel.
I still pinch myself the fact that I was able to teach a group of people to print. Many who had never worked with computers before and never seen a 3D printer before, and I taught them how to make arms. That's what technology has the potential to do. I have a process. And the process is you commit, and then you figure out how the heck you're gonna do it. The second I saw the story about Daniel, I didn't need to reread it. When you look at a picture of a boy with bandaged stump arms, I mean, what do? Do you just, oh, that's too bad, and close the computer and go to bed? What do? You can't put the pieces back together in someone else's life. But maybe if we print them new pieces, they'll start to learn to put them back together themselves.
Thanks, guys.